Okay, on page 5 of the notes, we're going to have a look at an example where we use the auxiliary angle method to graph something. Okay, that's one of the uses of the auxiliary angle method. Solving equations and graphing are two main uses. Okay, remember, auxiliary angle method is used when we've got a sine added with a cos and they've got the same period. Okay, which is this case here, and they're getting us to rewrite this in the form r sine x minus alpha. So first step is to write square root sine x minus cos x is equal to r sine x minus alpha. Okay, and now we're going to expand the sine x minus alpha. Okay, so that's going to be sine of the first, cos of the second, and then I'm going to straight away multiply the r out, so it's going to be minus, and there's going to be another r there, and now this time it's going to be cos of the first, sine of the second. So that's just me expanding that sine x minus alpha and also distributing that r for each term. Okay, now the next step when we use the auxiliary angle method is to equate coefficient of sine x and coefficient of cos x. So let's equate. Okay, so for sine x here, I've got that coefficient's root 3 on the left, on the right it's r cos alpha. Okay, and then equating coefficient of cos x here, I've got -1 is equal to, and the other cos x here is negative r sine alpha. Okay, and obviously those negatives can cancel out. You get 1 equals to r sine alpha. This is the stage where I always consider what quadrant alpha the auxiliary angle should be in. Okay, so remembering that r is a positive number, represents the amplitude of the final wave, it's going to be positive. So r is going to be positive. That means that cos is going to be positive, and also sine is going to be positive. So if sine and cos are positive, we must be in the first quadrant. So our auxiliary angle must be in the first quadrant. That's nice. Okay, we can always work out r by doing square root coefficient of sine x squared there, coefficient of cos x, which is -1 squared. Okay, so it's going to be 3 plus 1 square rooted, which is 2. So r is 2. You can jump straight to using this square root coefficient of sine squared plus coefficient of cos squared. The other alternative way is obviously to write this equation 1, equation 2, square, and then add. And then you can use sine squared plus cos squared as 1. Okay, to find the auxiliary angle, I'm going to do equation 1 divide equation 2. Okay, and that way we get a sine over cos situation, so there'll be tan alpha, the r's will cancel out, and we'll be getting 1 divided 2 is going to be 1 on root 3. Okay, that's an exact value, you should know. It's pi on 6 is the related acute angle, and because we are in quadrant 1, that means that alpha must be the related acute angle pi on 6. So therefore we can write root 3 sine x minus cos x is equal to 2 sine x minus alpha, which is pi on 6. Okay, so that's the first question done. Second part says, hence sketch that function, which is the exact same as the previous question, with the main 0 to 2 pi. So the key thing is basically to do B, we're sketching, let's use our answer from part A, y equals to 2 sine x minus pi on 6. Okay, if I wanted to sketch this, I'll go through all the usuals we do in 2-unit, the period, which is 2 pi divided coefficient of x, which is 2 pi divided 1, which is 2 pi. Everything important happens every period divide 4. Okay, period divide 4, which is pi on 2. So that tells me my spacing should be pi on 2. What else do I see here? I see that there's a horizontal translation. Okay, of well, the phase of negative pi on 6, which is a horizontal translation, pi on 6 to the right, because there's a negative in front, it's to the right. And we've also got an amplitude of the sine wave of 2. Amplitude of 2. The center will just be 0 because there's no plus anything at the back of the rule. So that should be enough information to sketch this. Now, based on the scale, we might adjust some things a little bit here. So I'm going pi on 6 to the right. So positive sign starts off at the center and then goes up, right? So we're going to be starting at the center and going up, but we're going to be starting from pi on 6 to the right. So let's just work out where pi on 6 is. This is pi on 2, which would be 3 pi's on 6. So divide this into thirds. Okay, so that'll be pi on 6 there. Now, every important thing happens every period divide 2, which is pi on 2, but I can also make that in terms of on 6. It's 3 pi on 6. So the spacing here is pi on 6. So I've got to go 1, 2, 3 spaces. So the next important point will happen here. That'll be at 4 pi on 6, which is 2 pi on 3. 5 pi on 6, 6 pi on 6, 7 pi on 6, 8 pi on 6, 9 pi on 6, 10 pi on 6, well, which is 5 pi on 3. And then 11 pi on 6, and then 12 pi, oh, okay. So I've put the key points bolded there. Alright, it might be good to work out where we start from. Well, actually, I'll just start from pi on 6 and go up. So the amplitude's 2, so I'm starting from pi on 6 to the right there. Sine starts at the center, and then we're going to go up. So up at 2 pi on 3, and then back at 0 at 7 pi on 6, and then down at negative 2 here at 5 pi on 3. And it would probably be good to work out the endpoint, okay? Because the period's 2 pi, and we're going from 0 to 2 pi, if I just work out the y-intercept by setting x equal to 0, so y-int set x equal to 0, you get y is equal to 2 sine negative pi on 6, okay? Now, sine is an odd function, so it's going to be negative 2 sine pi on 6, and sine pi on 6 is opposite over hypotenuse is a half there, so negative 2 times a half, which is negative 1. Okay, so we're starting off from negative 1, that looks reasonable there from my graph, and then because the period is 2 pi, we'll also finish at 2 pi comma negative 1, and I'll label that endpoint. Okay, I should have enough to graph this now, so let's try and graph this. Okay. All right. So there's the graph there. So that's part B done. Let's have a look at part C. C, find the first positive value of x where y attains its max. Okay, well, because we've graphed, that's very easy. The first positive value of x where y attains its max value of 2 would be from the graph, it's 2 pi on 3. So from graph, it's x equal to 2 pi on 3. Imagine you didn't have a graph. How could you do this question? Well, you would go back to your rule and you would go, the max value of this guy is going to be 2 because the amplitude is 2 and the center is 0. So max when y is 2, so you get 2 equal to sine x minus pi on 6. You would divide by 2, you'd get sine x minus pi on 6 is 1. Okay, and then you'd think about the values of sine, where sine equals to 1, and the first positive one should come from pi on 2, okay? And then you can just add the pi on 6 there, and you'll get 2 pi on 3. Alright, one last thing to note here down the bottom. Note that comparing the single sinusoid compared with the pair, it has the same period as the individual two parts. Okay, it still has the same coefficient of x. It can have a different amplitude though. This one has an amplitude √3, this one has an amplitude of 1, this has an amplitude of 2. And there is the additional horizontal translation, which is due to that auxiliary angle here, which is the minus pi on 6 for this question. Alright, what I'd like you to do is keep working on 8.1. See you in the next video.